Hey guys, welcome back sa ating channel. So this is the part 2 of computing deflection and slope of simple beam using double integration method or DIM. So sa part 1, i-compute tayo ng deflection under concentrated load. In the part 2, so under uniform load naman tayo. Under uniformly distributed load sa ating simple beam. So ganun lang rin yung step. So nagka-cut lang tayo dyan. So siyempre pag simple beam, meron tayo dyan tatlong reactions. RBX, yung horizontal reaction sa hinge support, and vertical support, vertical reaction sa ruler at sa hinge. So, first step sa DIM is computing the reactions. Tama? So, para makumpit natin sa RA, summation moment tayo sa B. So, yun lang yan, RA times 2, moment arm L minus W times L. Omega, which is yung load natin, uniform load, yun yung nabago. Uniform load times L, yung length, times yung centroid, since rectangular ito. So, nasa center yung centroid ng ating load, so L over 2. So, rearranging the equation, so RA is equals to RBY is equals to WL over 2. So, paghahatian lang nila yung ating load. Tama? Next. So, yan, nagkatayo doon. So, magkakatayo dito. So, part ito, nagkatayo dyan. So, it is the distance x. So, yung mabaliwala na yung L kasi distance x na lang yan. So, the centroid is x over 2. Okay? Katayo dyan. So, yung mangyayari, yung reaction is WL over 2. So, magdiderive po tayo ng formula para sa maximum deflection under uniform load. So, ito sa ginawa natin ng part 1, nag-derive tayo ng formula. So, integrate na moment tayo dito sa point na to. So, moment is equals to AIY prime is equals to RA, which is yung RA is WL over 2 times X minus W or omega times X over 2. Yung sabi ko kanina, yung centroid is sa gitna. So rearranging the equation, so RA times X, omega times X squared over 2. Then integrate. This will be our equation 1 or moment equation. So, integrate lang natin yan. So, i-recall lang natin yung power rules sa integral. So, integral of x raised to n is x raised to n plus 1 over n plus 1 plus constant. So, integrate RAX, magiging RAX squared over 2 minus WX cubed over 6 plus constant. That will be our equation 2 or slope equation. Then, integrate. So, deflection or EIY is equals to RAX cubed over 6 na. Minus 6 omega x raised to 4 over 24 plus constant 1x plus constant 2. That will be equation 3, deflection equation. So, yan. Yan yung tatlong equation na importante. So, kailangan natin may tama yung tatlong equations na yan. Tama ba? Pag nagawa na tayo ng tatlong equations, boundary conditions na tayo. Ito yung ating beam. So, yan yung ating elastic curve, o yung ating deflection curve, represented by that elastic curve. This is the tangent lines sa support A and B. That will be slope A, and it will be slope B. Okay? Boundary condition at x equals to 0, kasi dito nag-start yung x. Diba? Dito nag-start x pa kanan. So, ang x dito is 0. So, siya yung origin. So, siyempre, yung moment doon, meron tayong value ng moment is 0, pero may value ng slope. Slope is not equal to 0 and deflection equals to 0. Pwede gamitin yung equation ng deflection. So, yun yung deflection equation natin. So, equate lang natin yung deflection sa 0, then substitute x to 0. So, therefore, Z2 is 0. The next boundary condition is x is equals to L. Yun na sa point B. L distance to, diba? So, x equals to L. Moment is 0. The slope is not equals to 0 kasi yun yung slope B. Then, deflection at support B is 0. Pwede natin gamitin yung deflection equation. Substitute lang natin yung L dun sa x. So, omega L over 2 times L cubed over 6 minus double omega L raised to 4 over 24 plus C1 times L. So, ito na yun. I-relate natin yung equation natin. So, rearranging the equation, magiging W ay omega L cube over 12 minus omega L raised to 4 over 24 plus constant 1 over L. So, divide, i-transpose natin si C1 times L, magiging omega L raised to 4 over 24, so naging positive na siya, magiging negative naman yung omega L raised to 4 over 12. So, common denominator nila is 24, ay divide natin sa L para marehas. So, makakancel yung L, so magiging omega L cube over 24 minus double L cube over 12. So, common denominator is 24, magiging omega L cube over 24 minus 2 double L omega L cube over 24. So, 1 minus 2 is equal to negative omega L raised to 24 raised to 3 over 24. That will be our constant 1. So, yan yung gagamitin natin, constant 1. Negative omega L cube over 24. Then, next is gamitin natin, para makumpit natin yung formula ng maximum deflection, gamitin natin yung deflection equation. So, ngayon, i-locate muna natin kung nasaan ba ang location ng maximum deflection. So, gamitin natin yung discuss natin nakaraan. Sabi ko, kung saan yung, siyempre, yung maximum deflection, yun na yung lowest point. Sabi, di ba sa curve, yung highest and lowest point, the slope is 0 kasi yung tangent line is horizontal. Gets? So, kung nasaan yung maximum deflection, yung slope doon is 0. So, pwede natin gamitin yung equation na yun. So, dito sa ating problem, since symmetrical naman to, automatic na sa gitna yung ating maximum deflection. Okay ba? Nandiyan yung ating maximum deflection. Dito po. Yan yung ating maximum deflection. So, x is L over 2. Nasa gitna. So, pwede natin substitute yung L over 2 doon sa x. Magiging, so, makancel na yun kasi x is L over 2 minus L over 2 is 0. Okay? Magiging deflection maximum is omega L over 2. Which is yun yung reaction, RA. Tapos yung i-substitute lang yung L over 2 sa x. Magiging L over 2 cube over 6 minus omega L over 2 raised to 4 over 24 plus C1 L over 2. Okay? Ayusin natin yung equation. Magiging W L raised to 4 over 96. So, guess nyo naman yun, no? 2 raised to 3 times 6 times 2 is 96. Minus, magiging W L raised to 4 over 24. Plus, yung C1 natin is negative W omega L raised cube plus 24 times L over 2. Rearranging the equation, magiging omega L cube over 96 minus W L raised to 4 over 384 minus omega L raised to 4 over 48. So, common denominator nila is 384. So, 384 divided by 96 is 4. Minus omega L cube ay raised to 4 over 384. Minus 4 ng 384 divided by 48 is 8. So, magiging 4 minus 1 minus 8 will be negative 5. So, deflection maximum is equal to negative 5 omega L raised to 4 over 384. So, negative sign means that DIM means downward. So, formula natin for maximum deflection under uniform load is 5 omega L raised to 4 over 384 EI. So, pwede nyo yung magamit. Okay, tayo ng isang example na, so, sa case kasi na to, yung ating uniform load is sa buong span. Paano kung binigyan tayo ng problem na sa kalahati lang or sa gitna lang yung uniform load? So, hindi na applicable itong formula na to. Tama? So, this formula is applicable lang yung pag sa buong span merong uniform load. So, paano nga kapag may kalahati lang na uniform load? Or 3/4 or nasa 1/4 lang? Basta may part lang na beam na under uniform load. So, gamitin natin ang double integration method. So, yung double integration method yung susi. So, tuloy natin itong problem na to. A simple beam shown is loaded 30 kN per meter, distributed half of its span. Using double integration method, calculate the maximum deflection and slope at supports. So, this is the problem. 30 kN from midpoint to point B. So, total itong beam natin is 10 meters. So, solution. So, draw muna natin yung free body diagram. So, meron tayong tatlong reactions, BX, BC, Y, and AY. So, para makomplete natin si AY, submission moment tayo sa B. Para makomplete si BX, so since wala naman tayong horizontal load, so BX automatic 0 yan. Submission moment tayo sa B, clockwise positive. So, AY times 10 minus 30 times 5, which is yung force pa lang yun. This is force. 30 times 5 times centroid, kalahati ng 5 is 2.5. So, AY will be 37.5 kN. So, BC, submission force vertical lang yan. So, AY plus RB is equals to 30 times 50. So BRB will be 112.5 kilonewton. So since ang kailangan na natin dyan is AY, kasi dito tayo magka-cut, diba? This distance X. This will be distance, ano to? Since ito ay X, this will be X minus 5. X, bawasan natin ang 5 na to. Okay? So, yan. Mag-integrate na tayo. Nag-cut tayo sa part na yun. So, nang moment tayo dito, moment tayo dyan. So, magiging 37.5. So, yung distance X, this will be X minus 5. So, moment is equals to 37.5 times X minus 30 times X minus 5. That is, force ko lang yun. There's distance X minus 5 over 2. So, rearranging the equation, magiging 37.5 x minus 15, kasi 30 divided by 2 is 15, x minus 5 squared. Then integrate natin yung moment equation. So, 37.5 x squared over 2 minus 15 over 3, x minus 5 cubed, plus constant 1. That, na rearrange the equation, 37.5 is 18.75 x squared minus 5. The 15 divided by 3 is 5, x minus 5 cubed plus c1. Then, integrate the slope equation. Integrate natin, magiging 18.75 cube ay over 3. X cube minus 5 over 4. X minus 5 raised to 4 plus C1x plus constant 2. That will be after our deflection equation. So, then, boundary conditions. Then, 18.75 divided by 3 is 6.25. Then, 5 over 4 is 1.25. Decimal lang. Pwede nyo rin ito gamitin kung gusto nyo. I-arrange na natin yung ating equation. So, para madali. Okay, proceed tayo sa boundary conditions. So, first boundary is x equals to 0. So, moment is 0. Slope is not equals to 0. So, deflection is 0. So, C2 is 0. So, yung mga boundary, yung mga values sa boundary, depende po sa support. Pag naka-fixed support, automatic may moment tayo sa fixed support, di ba? So, wala tayong slope. And wala tayong deflection. So, ganun, depende po sa support. Since ito is roller support, so wala po diyang moment. May slope, pero wala rin deflection. So, ganun po. So, therefore, C2 is 0. Hindi ko na pinakita kasi substitute lang si X sa 0 sa X. So, magiging, makumpit natin si C2 is 0. Next boundary condition na tayo. At X equals to 10. Substitute lang yung 10 doon sa substitute lang natin yung 10 dun sa ating x. So, deflection equation. So, 6.25 x cubed minus 1.25 x minus 5. Raised to 4 plus c1x plus c2. Since ito is 0 na yan. So, magiging c1 is equals to negative 546.875 kilonewton meters squared. And locate the maximum deflection. Since ito yung ating beam, yun yung elastic curve natin. So, then the tangent lines. Gamitin natin yung idea na kung saan yung that will be slope A, slope B. Sabi ko diba, kung saan yung maximum deflection, ang slope dun ay 0. Kasi dun yung lowest point, yung tangent line is horizontal. So, gamitin natin yung slope equation. Kasi yung slope is 0, that's the location ng maximum deflection. So, yan. Kaso gagamit tayo ng mga assumption. Mag-assume tayo. Ang unang assumption natin, yung maximum deflection natin is nandito lang banda. Assume natin ibig sabihin nasa pagitan ng 0 at saka 5. Yan yung boundary niya. 0 to 5 yung ating location ng maximum deflection. Since, di ba sabi sa NTIM, kapag nag-negative yung sagot or nag-0, so hindi na siya isama sa equations. Kasi kung ang assume natin is bumaba siya sa 5, so automatic to is mag-negative. So, hindi na siya isasama sa equation. Tama? So, magiging equation natin is 0 is equals to 18.75 x squared minus 546.875 yun yung C1. So, dapat ang lumabas na value dyan is mababa sa 5 pero mataas sa 0. Okay? Calculating, lumabas is 5.4062 meters. So, hindi niya na-satisfy itong yung assumption natin. So, assumption is wrong. So, hindi natin gagamitin yung 5.4 meters. So, mag-ano ulit tayo ng boundary or mag-assume ulit tayo kasi ibig sabihin kung hindi tumama yung unang assumption, ibig sabihin ang location ng maximum deflection is nandito banda Nasa pagitan ng 5 to 10. Is greater than 5 but less than 10. So, gagamitin na natin itong buong equations. So, ganun po sa DIM, hawag kayo dito. So, 0 is equals to 18.75 x squared minus 5 x minus 5 cubed minus 546.875. So, calculating, lumabas na value ng x is 5.4022 meters. So, tama siya. Siya yung gagamitin natin value.
Okay.
X is equals to 5.4022 meters. Yan yung substitute natin dun sa deflection equation. 6.25 x cubed minus 1.25 x minus 5 raised to 4 plus c1x. Substitute lang yan. Calculating, makakompute natin value is negative 1,969 kilonewton meter cube in terms of PI. Okay? Yun yung maximum deflection natin. Then, slope at support A, gamitin lang natin yung slope equation.
Okay.
So, sa A naman, ang x dyan is 0. Substitute lang sa x is 0. So, deflection A will be, yun yung value ng C1. So, negative 546.875 kilonewton meter squared or clockwise.
Kayo na ako mausap dito, ha? Nakakapikon to, hindi ko maintindihan eh, ha?
Clockwise siya. So, clockwise siya. So, slope B, ay slope C, slope B and slope B. So, substitute lang natin yung 10. Since yung 10 naman yung from point A to point B is 10. So, palitan na natin yung x ng 10. So, magiging deflection ng slope at C is 703.125 kN meter squared. So, mas malaki yung value ni slope C kaysa slope A kasi mas malapit yung maximum deflection sa point B. Tama? Mas malaki yung slope dito sa slope B. Mas malaki yung buka dito sa B kumpara sa A kasi mas malapit na yung maximum deflection sa point B. Tama?
Okay.
Napasa sa gitna na 5.4 nga. So, from point B is 4.6 meters. Okay? Okay, try nyo tong problem na to using double integration method, combination ng... Okay, nga pala. Yung problem na to is pag ganito yung case, may formula ba? Yes, may formula tayo. Ito po yung case natin. So, para makompute natin yung slope, A at saka B, ito. Ang formula A at saka B. Kung makompute nyo makompute yung maximum deflection, ito po yung formula. Substitute nyo lang yung location dito sa X. Yung A, yun yung 5 meters. Tama?
Okay.
Sabi ko nga, kung kayo tatanungin, kung marunong naman kayo maggamit ng DIM, so again, hindi lang DIM yung pwede natin gamitin. Sa next video natin, madidiscuss natin ang double ng area moment method, conjugate beam method, superposition method, o pwede ring virtual work method, pwede ring may isa pa, nalimutan ko yung term na Castigliano's theorem.
Galing yan.
Pwede natin gamitin yun. So, kayo, kung papangarapin nyo mag-memorize itong mga formula na to, para sa akin, so, di ako kayo nire-recommend na mag-memorize ng mga formula. Since marami tayong alam na method.
Galing yan.
Diba? So, note of formula tayo. Dito tayo sa method. Madali lang naman, diba? Lalo pag nalaman natin yung area moment, tsaka conjugate beam, at tsaka yung superposition. So, yan. Yun lang yun naman sa akin. Bahala kayo kung gusto nyo gamitin yung formula to. So, napakahaba niyan. So, marami pang case. Kung sasaluhin nyo lahat ng formula, baka mabuang kayo. So, dito na kayo sa method na tinuturo natin. Okay?
Okay.
So, try nyo itong problem na to.
Suluhin mo yan.
So, meron tayong simple beam ulit. So, A, B, C, D. 30 kN at point B, 10 kN per meter, C to D. Yan yung sinasabi ko kanina. So, wala tayong formula para dyan. So, meron din yata formula. So, hindi ko lang alam yung formula para dyan. So, gagamitin natin ng DIM. Since DIM pa lang naman yung nating nadidiscuss. So, gamitan nyo ng DIM para makompute yung... So, given pala yung modulus of elasticity and moment of inertia, 2,340 times 10 raised to 6. Yun. Given yung modulus of rigidity ng ating beam. So, compute natin yung deflection at point B, deflection at midspan, slope at point E, and compute the slope at support A, and determine the maximum deflection. So, using the AMA. So, try nyo i-compute yung problem na yan, and i-comment nyo agad sa baba yung sagot. Sino yung unang-unang maka-comment ng tamang sagot sa 5 questions na yan. So, may hinanda akong sorpresa.
Oh my God! Wow!
Bibigyan ko ng premium na gawang SIM card. Okay?
Okay.
So, sana masolve niyo yan. Madali na yung problem natin. So, para sa go mo. I-comment nyo lang yung sagot niyo sa baba. Yun. Then, message nyo ako para makuha niyo yung premium. Okay? So, para maano na kayo, para maganahan kayo mag-solve. So, madali na yung problem natin yan. Kakat lang kayo dito. So, turon, ibigyan ko kayo ng cut lang kayo dito. Kakat kayo dito. Okay? So, ang magiging problema lang dyan sa DIM, kahit naman sa area moment, ganun din yung problema. So, hindi siya abot nung sa tayo nag-cut. So, gagawin nyo dyan, lalagay kayo ng yung dummy loads na tinatawag. Na 10 din yung mag-retune. So, naglagay kayo ng bababa. So, sagad na dito. Okay na yan. So, para di mapektuhan yung reactions natin, so, lagay din kayo ng pataas kung ilan yung nilagay niyo bababa. Okay? Saka kayo mag-integrate. So, binigay ko na yung clue para paano makatakikin yung ganyang problems. Okay?
Okay.
Cut kayo, then lagay kayo ng dummy loads. Para sa mga SIM card. Okay? Sana nakikinig kayo sa video. So, kung may gusto kayong request na i-content natin sa nasunod na video, i-comment nyo lang sa baba. And thank you. Bye.